Right, we are now at Unit 3 of Technology, page 8, still chapter 1. In the previous video, we did Unit 1 and 2, which dealt with electrical pylons, how you strengthen the electrical pylons, and how compression, tension, and torsion forces are made and what they look like and the understanding of it. So now we're going to go to structures that span over space. So you're right here in the first paragraph, you'll see I underlined over here where it said there are many situations where structures are needed to span over spaces, such as over banks or of rivers, over roads, or parts of a building. So there's three scenarios where you want to span a structure over space. And now we're going to go to the next paragraph over here where it says beams in structures. So everything I have already underlined, you can just see in the video, you can pause the video to see everything underlined, that is important so you can learn this for your tests. So the first sentence is, beams, also called girders, are used to support loads over space. So you please need to know this word girders over here, and you must know that this is the purpose of the beam. It's used to support a load over space. So, second sentence is, a beam is a solid structure that lies in a horizontal position. So all of this I've already underlined, which describes what the beam is, what the purpose is, which is important. So right over here, in this figure over here, it shows figure 1.25. Here it shows a beam. You see this beam looks like it's made of a piece of wood. Therefore it is solid and it is lying in a horizontal position. And this distance between your gaps is your span. Beam and the span. You guys must know the span over here. So here are I-beams. Different types of beams and how they look. The I-beam is the most steel beams have an I-cross section. This provides strength, stiffness, and uses the least amount of steel. So there are three positives about using an I-beam. So in a test, it can ask you list three advantages and three disadvantages of having an I-beam. And right over here, here's three advantages right over here. Strength, stiffness, and it uses less amount of steel. And because it uses a little amount of steel, you'll see over here underlined, it has the least amount of weight. Since over here, I made like a little gap over here, all of this over here is just air. So in here, in the previous drawing, you see here it's everything is steel now, and here's so all of this now is extra. So it's extra weight which we don't need. So it's less steel and it's lighter in weight. And because there's less metal being used to make the I-beam, it costs less. So those are some positives about it. So here's another one. So there's 4 and there's 5. So there's 5 positives about the I-beam and why it is used instead of a normal rectangular beam. So now we're going to go to lintels. Now lintels you will find in window frames, in door frames, to give it strength for in case there's an earthquake or to provide a stable foundation for the wall to lie on. So you'll see lintels are the wooden or concrete, so it's made of wood or concrete. It's two materials it's made out of that support the walls above windows and doors in houses like I just mentioned, and other buildings. It can be any building. If you walk into any building, you will see that there is a lintel above a door and below the window and above the window. Right, now going to page 9, the beam and column bridges. Most bridges over highways are constructed of beams. You look at that, just a long beam going all the way through. Some of these are beam and column bridges. So you must please know this. It's a beam and a column bridge. So here's the beam and here's the column keeping it up. All these columns keeping your bridge up. Beam and column bridges. This type of structure is used for a bridge with a long span. So you only use a bridge and column when it is a long span, so if it's a long distance. The bridge is made of beams that have a shorter span than the bridge, so this avoids the need for big, heavy beams. So you'll see over here your bridge is cut into sections. You have like a little at every single column there's like a little section where each beam lies on each column. So there's different sections of the beam which makes the entire road. And it says right over here a shorter span in the bridge, and this avoids the need for big heavy beams. Because if the whole thing was one giant long beam, then it would be very heavy and almost impossible to move. And since it's sectioned in little parts, it's easier to move around. So it allows the bridge to expand. So it also allows the bridge to expand and contract with changes in temperature. So if you guys didn't know this, cement will contract and expand depending on if it's hot or cold. Now since there is gaps in between here, each of these parts of the bridge will expand and contract in their own way. If the whole thing was one thing, then the whole thing would expand or contract. And if that happens, then the bridge could collapse, it could break, and that could cause a lot of problems because people can die, a lot of money can be lost, time is wasted, and resources are also wasted. So now going to alternative bridge supports instead of using a column and a beam. Now here, this is the first one, is a suspension bridge. Suspension bridges are used where the space that must be spanned is very long. Just like the beam and column bridge, it's used for a long distance. You can also use the suspension bridge for long distance. These bridges are mostly used to span a wide expanse of water. So it's usually used when there's water. So the beam and column bridges are used on land, and the suspension bridge is used over water, where it's not possible to build a beam bridge. So figure 1.30 shows that the two types of cables in a suspension bridge. The main cable, you guys must please know this, the main cable right over here, just follow the line, is this one going down, sloping down at an angle. So this one over here, which looks like half a circle, that is the main cable. And the suspended cables, those are the ones going vertically down. The main span is the distance between the towers. So just like you saw in page 8, there is two gaps over there, that this is the span. Now it could get a little confusing, causing people to think that this over here is the span from the end to the beginning, but it's just from the two columns. The distance between the two columns is the span. Going to page 10, here's your second bridge. This is the cable stayed bridge. So here is also like a little example of this suspension bridge over here now, which people made with a chair. Now we're going to the cable stayed bridges. So a cable stayed bridge is more modern design that can be a positive, that is suitable for short and long spans. So this can be used for short distances and long distances. You have learned that the suspension bridge has two types of cables. A cable stayed bridge has only one type of cable. These cables support the deck directly from a tower. So it doesn't tell you which type of cable it's called, if it's like over here where it specifies that it's a main cable and a suspended cable. So you guys just need to know that it is just a normal cable. You guys don't have to know a special word for it or anything. Just a normal cable. Going to page 11. Almost finished with unit 3. So now we're going to arcs in structures. An arc is half a circle. So long before the development of reinforced concrete, iron and stone was one of the materials that could be used to span long spaces. So in the past, there was no steel, there was no iron, there was no reinforced concrete. So they had to use stone, and this is important. The problem is that stones laid horizontally cannot span over a space more than the length of its just one stone. So you'll see over here, here's a specific length. Now you can't have several different pieces of stone over this one span, because otherwise they will collapse, it will just fall, unless you have like support underneath maybe. But they didn't know about this, and they didn't have it, so they just had to make one solid, you had to literally have one solid piece of stone which covers the whole span, otherwise it wouldn't work. And that is where arcs in structures come in now. Right now you'll see here, if we go down, there's like a little picture of it. So let's just imagine that these are the stones now. You would then go and put an arc of stones below your span of stones, and now it creates support so that it wouldn't collapse. And there you'll show a little picture over here of how it was made. There's the arc in the structure to make your door frame rigid. Going to page 12, the last page of Unit 3. Nowadays, arc bridges are made of reinforced concrete and not stone. You guys must please know this. It now uses reinforced concrete. So now it just tells you over here, the Blokons Bridge is an example of this on the garden route. So this information isn't really useful. You guys won't get this in a test or exam. So you guys don't have to worry about that. So we get carrying on to the second paragraph. Dam walls are sometimes built in an arc design because this shape is stronger than a straight wall and it does not use as much material. So you guys must please know this. It's sometimes built in an arc design, just like we learned the arc structures over here on the previous page. And the reason why is because the shape is stronger than a straight wall and does not use as much material. So there's two reasons why you prefer an arc dam wall over a straight dam wall. We're almost finished with the unit. Cantilevers. Simple state cantilevers can be used in bridge construction. There's two types of cantilevers. There's a simple cantilever that are similar to beams, except the cantilevers are supported at only one end. Like over here, there's a lot of weight pressing down on this beam over here, and that keeps it up. And the other end is free. The other end must be built into a supporting structure, like in figure 1.40. Now the other one is almost the exact same as a simple state cantilever. It just uses cables as well. So right over here, you'll see that this beam over here is supported onto the wall, and you just have a cable at the end of it, pulling it to keep it up. So they are used to strengthen, to stabilize, and can extend further. So there's two reasons why you would choose this one. And because of this, it can extend further, and is sometimes used to support the roofs of sports stadiums like over here. That is all we're doing for Unit 3. Good luck for studying and for the tests.